Hey, buddy. How are you?
Okay. I was watching a little bit of the news.
Yeah.
And I found out what the coronavirus does.
Yeah. What does it do?
It
just makes you sick.
No, for grown-ups like over 65.
Okay.
It stops your lungs from working.
Well, but don't worry.
Yeah.
We will.
But in this house, we'll be safe.
We'll be safe. Don't worry about stuff like that. I needed. Oh, yeah, YouTube. Here, we're gonna go YouTube. Put a shirt on. You can't go no shirt on, but if you want to come down and say hi to everybody. See, we're
Is
going.
this for you?
No, this is my students.
Oh yeah, that's what I meant. And Dale, I want to start a YouTube
Okay.
channel.
All right. Hey, today, when I'm done here, we'll go for a little hike.
To where?
But we gotta be good on the outdoors, okay? So you can play with the computer now.
One?
No, not that one. That one Danny does work.
Why is everyone doing it?
Hey, everybody. What do you call a dinosaur that's sleeping? A dinosaur. How's everybody doing this morning? Hopefully everybody's pretty good. Let's talk. Who's online? Say something. I don't want to be here alone. It'd just be creepy me talking into a microphone. Why anybody tell me how fat I was? They say the camera adds like 10 pounds. How do I count for the other 30? Jeez. I gotta go on a diet. All right. Hey, look at all you guys. I'm tearing up. See? Nothing like a joke. All right, here's the plan. We got still more problems we should go over. People are asking about a few problems. A few people asked about number number 30. Now, you got to give me more information. Is this number 30 like I saw you explain it, Mr. Noah, and I still have a question on number 30. I looked through the video that we explained it. It was day 2, somewhere around 33 minutes. We talked about number 30. Or is it like I'm still totally confused by that concept. Okay, so we were talking about concepts. So let's take a look at 30 one more time. But also number 14. Someone asked about number 14. We didn't cover number 14 either. So let's start there while everybody's waking up. Okay, let's take a look at number 30. Or I'll put it over here. Okay, number 30. It was this one. It was the one that looked like this. Okay, you could take a look. It said we're doing a Riemann sum, a right Riemann sum. Okay? Can you hear me? How's that sound? That's a little better. A right Riemann sum. Now remember how we did Riemann sums. Okay, when we're doing a Riemann sum, okay, all we did was we just started and we said, all right, for a Riemann sum, we found the here's whatever it looks like, and we'd make a bunch of rectangles. Okay, well, I did a left Riemann sum, but you get the idea. Doesn't matter. Okay, we do a bunch of rectangles, and we say, all right, the area is approximately base times height. Right, base times height. Okay, blah 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 blah. Okay, and we say, well, the shortcut way to write this is the summation of some formula here, base times height, whatever that formula is. Okay, now, for example, just for fun, okay, remember back in Algebra 2, okay, if I said the summation of, say, just, let's start at n, no, let's not use n, let's use I equal 1 to 50, okay, of I. Now, remember what that is. That's 1 plus 2 plus 3 plus 4 plus all the way to 50, okay? That's just a notation. Now remember, back in Algebra 2, we had some strategies on what this whole summation equals. For example, the sum of the first 50 numbers is this formula. You take n over 2, and you take the first number plus the last number. We had a nice little formula for that. Okay, so in this case it's 50. If I add the first 50 numbers, it's 51 times 25. There was a but, and that's what this whole summation is equal to. So this is equal to. So sometimes you could figure out what the summation formula is. Okay, so that's what this problem is saying. This problem says they did a right Riemann sum. They did this, and they figured out that this summation, whatever the rectangles, whatever the formula of rectangles that we added together, that summation is equal to 2n plus 1, 3n plus 2 over n squared. However complicated that is, they said that summation of the Riemann sum, it's the summation of base times height plus base times height plus base times height, that summation is equal to that. Okay, that's what they're saying. If this is a little confusing to you, this was in Algebra 2 in series and sequences, where we came up with some little formulas on how to figure out what the summation is. And there's a lot of formulas out there. You could take a look. You could look that up. Okay, so they're saying this Riemann sum summation is equal to that. Okay, now we did, let me change colors here. We know that the area, let me take that progression again. The area is approximately the summation from n starting at 1 to whatever. I'll put a little big, I don't want to use B. Okay, hold on, let's not use n because n means something else for you guys. So we said the area is approximately the summation, and we use I equal 1 to n of whatever the base times height is. Which what they're saying here is that's equal to this formula. Times 3n plus 2 over n squared. That's what they're saying. They're saying that's equal to that. Okay, so now we know that the actual area equals, if we take the limit as n approaches infinity, if the number of rectangles goes to infinity, of this summation. So we know we're going to take the limit as n approaches infinity of this, which is what the summation equals to. Times 3n plus 2. You see that? That's what the problem is saying. Now, when we have data, when we have a data example, we calculate that summation because we only have like 5, 6 rectangles, and we could calculate that by hand. Okay, but this formula would be our calculation for the summation. You see, if we calculated the rectangles and add up to 35, this formula would get us 35. So to figure out the actual value of the integral, which is a limit, we take the limit of this, and that was 6 from there. Okay, so that's a quick explanation of 30. People were asking about that. Look on the other video also. We took a little more detail to that, but I think maybe this is the part that's confusing people. If not, then say something. Say something in the comments. I think that's the part that was confusing people, that where is this formula coming from? Okay, and that formula is a formula for the summation. And there's a bunch of there's tons of formulas out there. There's a formula for quadratic. There's a formula for multiplying. There's a lot of geometric series, arithmetic series, a lot of different formulas that people have worked on to come up with stuff like that. Okay? Let's also, someone asked in the comments, someone asked about, is that okay? How are we feeling on that? Give me some feedback while I get number 14. A couple people are asking about how do you do, still stuck on number 14. Okay, take a look at 14. Okay, and excuse me. This is one we talked about the yeast going on, the yeast population up. So you got to help me out where you're confused by this. Okay, so first of all, I see the first instinct is to say, all right, they're telling you that the rate is 24, and so you put a slope of 24 right there. And then the y-intercept at time equals 0 is 20. So I could see how your first instinct would be D. Okay, hopefully you have your PDF in front of you or online in front of you so you can see that a little better if you can read the whole problem. But we went over something similar to this. But it's saying it's a differential equation. Okay, so remember in our binder, the differential equation, as soon as we came across a differential equation, when we say this differential equation here, dy dx, in this case, t is equal to ky. That right away goes to ce to the kt. Y equals. This means this. This is the standard, the very first differential equation we studied. Okay? The very first one. Exponential growth. Then they're also telling us when t equals 0, the yeast population, which was y, is equal to, and then the rate, dy dt, is equal to 24. Okay, so we got two equations. We're trying to come up with this equation. Notice this equation has two unknowns, c and k. Okay, so all we got to do is plug in this information to both of these equations. Now, the problem gave us all this. Here's what the problem gave us. The problem gave us this and this. Well, you have to know this produces that. Now, we could show that. We could show the separation of variables, but take a look at your binder. That's just the standard one. It's shown in your binder already. We did that already. Okay. So all we could do is plug this information in here. This is the one that we had to know from this. And then we just go, okay, well 24, k, y is 120. There's that. Plug it in there. Y is 120. C, E to the K, 0. So you just plug that information into both of those equations. You got two equations, you got two unknowns. You should be able to solve that. Plug that information in, and K winds up to be 1/5. Gone. C winds up to be 120. So our formula is 120 e to the 1/5 t, and that's B right there. Okay, so a couple people asked about 14 also. So though that's the old business right there. All right, so if you're feeling good about that, if you're still, there's still some that you want to talk about, you bring it up. Okay, but here's the new business. Okay, we're probably going to get a reading of how the AP test is going to be distributed tomorrow. Okay, probably you're going to get a couple. I've been hearing, I don't know for sure because they're not going to post it yet for sure, but my sources tell me probably it's going to be, you're going to have two choices of days to take it. It's probably going to be online, and you're going to have to just upload your work right there at that time. We'll practice it when we know exactly how it's going to be. But it's going to be open notes. It's going to be with calculator. So that's where the binder is going to be really, really helpful because it's going to be a time test. So you'll probably have only, I don't know, like 40 minutes, an hour, 45 minutes, somewhere around there. A time test. You're not going to have time to fumble around looking at your stuff. So we want to make sure your binder is all set, all ready to go. So that's what we're going to work on tomorrow. And if it takes to Monday and stuff like that. So I posted on Schoology what we're going to do, but Schoology is probably going to go down in like 10 minutes. So if you take a look, hey, I posted on Schoology, and get this off of Schoology while it's still working. These are the objectives, okay? So on Schoology, I posted this PDF, and those are the objectives for AP, all of AB and BC. Now remember, BC is 1, 2, 3, 4, 5, 6, 7, 8, not 9. And on 10, okay, I put it in there, but 10 is only a couple of these. It's not every single one of them. It's just a few of these, like 10.2, 10.5. You see what I mean? Okay, 10.8. Okay, so take a look at those ones I said. So now, okay, I posted on Schoology, and like I said, get it quick. Download that if you want to. Grab it while Schoology's working. All right, so now what I want you to do is I want you to read through these, okay? Read through these objectives right here. Okay, read through all of them. Let me just show it. Okay, have your binder. And then go through one by one and say, do I have this in my binder? Here's where you could organize your tabs. Here's where all that prep work that you did before is really, really paying off right now. Okay, if you cannot find something in the binder, if you're like, I don't get that, because remember, in those pages, let's say we're talking about integration. And remember, we had a lot of little hints on what to do. How you're setting up a Riemann sum. Okay, are you using a known geometric? Oh, what are the hints we have to remember about known geometric? Below the x-axis. We put a lot of hints around that. And luckily this year you're going to be able to just look at all those notes. You don't have to memorize it or anything. So go through with each objectives and look at the first one. Okay, rate of change. Okay, definition of a limit. Estimated limit values from a graph. Estimate the limit values from a table. See if all that is in your binder. And then organize it and tab it. Okay? And then starting tomorrow, I'm going to say, all right, who doesn't have something? Who doesn't understand what this one's saying? Do you have look at here, do you have the inverse trig derivatives? Is that right there in your binder? Do you know what's the things we got to pay attention to? Oh, chain rule when we take that derivative. Where's the chain rule on something like that? Okay, L'Hopital's rule, is it there? Well, what's the thing you're supposed to write on L'Hopital's rule? What's the preamble for L'Hopital's rule? Each one of these, there's always those little things that, hey, don't forget, this should be written down. This is the part that people messes up. This is the part that people get wrong. Okay, so do you have partial fractions? Right there, partial fractions. Do you have that where you can find partial fractions? You see what I mean? So that's what I want you to do. Okay, I want you to read through this with your binder in front of you and be like, all right, I don't know. We got to talk about that. I don't get that. I can't find that in my binder. What is that particular one talking about? Or, hey, what are the hints that we were supposed to do about a slope field? And we're going to keep, doing practice problems and things like that so we could find out what the hints are and what we need to be doing. So does that make sense? Okay, here's where you say, do you understand what is being asked of you? Now, your assignment, like I said, I have to give an assignment. Your assignment is going to be just post here on the comments, because Schoology will probably go down in an hour or two. Post the comments, which ones we should talk about, so I can prepare some stuff for you. So which ones we should talk about, or on Schoology also, you could post comments there too. And as you notice, I started putting, grades. Hold on, let me use the air quotes, grades in, because we're supposed to keep track. Every day we're supposed to keep track that you're doing something every day in calculus. So, today, so if you post and say these are the ones, or you say you got them all. You say, I found them all in my binder. I did great, Mr. Noah. I put my binder together. Hey, that's what you're supposed to do. So if you did all that already, then just say, I'm good. I don't need to worry about this. Just let me know that we're engaging. That's the key word that we're getting yelled at for. Make sure we're engaging with the students. So I'm engaging with you. How's that? Okay? So if something's confusing, send me a message. I'm always checking my mail during the day. We took a hike in our backwoods. We found a fort. Someone was building a fort in the back, in our association woods. So that was cool. The boys found that. What else is going on? They're playing a lot of Minecraft. I don't know. That's about it. All right, so let's start working on some problems. Like for example, this one here. Take a look. This one, a lot of people got wrong. Okay, take a look at that one there. If you're printed out your quiz or test or whatever you call it. This is on the test though. Okay, it says 37. If you were online, number 37. But remember, on the test, they start at 70s. So this is, let me find it. This is number, hold on. Which one was it? I gotta find it. Flipping through. As it started, if this is 37 and the other one ends, it should be 7 in. 1, 2. Everybody find the number? 3, 4, 5, 6. A particle. Here we go. This is number 82 if you printed out the PDF. Okay, if you printed out the PDF of the multiple choices that I gave you, this is number 82. Okay? And a lot of people got this one wrong. Only 2 people got this one right in first hour, so let's talk through it. A particle travels in a straight line that gives you the velocity. Okay? We have the velocity. And then it's with calculator. Remember, I look at all the choices. They're all decimals, so I know I'm going to be grabbing my calculator right now. What is the total distance traveled during the first, from 0 to 2? Okay? Fine. How do we find the total distance traveled? Is basically what the question is. If we have the velocity, okay, what do we get the distance traveled? Now, what do we got to pay attention to when we're talking about distances? Remember, if I just integrate, let me get a clean sheet here. If I just integrate the velocity, that's not the distance. The integral from 0 to 2 of v of t dt is equal to the displacement. Okay, that integral is the displacement. Okay, that's important if it's in your binder. The total distance that something traveled is the integral from 0 to 2 of absolute value of v of t dt. So I'm thinking a lot of people made the mistake by just integrating the velocity. Let's check it out and see what happens. Okay, the first thing I do, as always, on my calculator, I plug in the double, triple check. Make sure you plug everything in. Make sure you plug everything into your calculator correctly. Let me clear all the old stuff out. Plug it into your calculator. We got 3e. Okay, need the glasses on. 3e to the negative x divided by 2 times sine of 2t. Okay, so plug it into your calculator. Double check it's in your calculator. Okay, so now I want to integrate. Now let's just double check. I betcha it could be. I bet when people went from 0 to 2, they just put in to the regular function. Let's see if that was a good distractor. When they just calculated the regular function, 1.85, and yep, see? A lot of you said B. 12 of you said B. So what do you got to write down in your binder right now? Distance versus displacement. Displacement is just that integral. Distance, you have to put the absolute value, which isn't too bad on the calculator. All we got to do is go in here and insert the absolute value. It's under math, number. We want to put the absolute value of, back to our y. Let me delete that part. You see that? Just put the absolute value of y1 in there. Hit enter. It thinks a little. And we should produce, dramatic pause, 2.26, which is the answer. Easy fix. Okay, so get in your binder as soon as the question, when it says distance, that you tab over to distance, and you have distance and displacement right there. The integral of velocity is displacement. The integral of absolute value of velocity is the distance. Okay? Does anybody have, well, since you're on now, take a look at what your questions were. I want to cover your questions before we run out of time here. Does anybody have ones we should talk about? I was just going over the most missed ones, but as you're looking through the PDF or online, is there any that we should talk about? Hey, I'm just going through and checking out the number 19. Yeah, you get your, hey, number 19. If you're online, you get the bonus. Can we go over 26? Good. See, that's what I like to hear. 19. Let's look at 19 here. All right, 19. We got function f of x. Approximation, okay, using the tangent line. So we're using the tangent line. So, okay, remember what we're talking about here. Number 19. I'll put 19 right up there at this time because those people who are not watching the video just posting some junk in chat. You can say, hey, how do you do number 19? I'm sorry, am I making fun of you guys? Okay. We need another joke then, since I'm making fun of you. You know, I was trying to put my kid to bed last night, and he didn't want to go to bed, so I called the police because he was guilty of resisting arrest. Wait for it. All right, so we want to find the equation of the tangent line, okay, and we want to use it to approximate the value. No calculator, though. So what we're doing here is we got f of x is equal to 2 cosine of x plus 1, right? We want the, what do we need? What do we need to find the equation of a tangent line? Okay, we need the value. We need a point at pi over 2. We plug in pi over 2, no calculator. What's cosine of pi over 2? 0. Remember, you could pause the video when you're thinking. We were watching, who were we watching? Some science guy. Mystery Doug. We were watching Mystery Doug, and Mystery Doug says, because I'm learning how to do this video chat thing, and Mystery Doug, he says, all right, we're going to pause the video right now, and you could discuss it. And so maybe the teachers talk about that. Anybody know who Mystery Doug is? He's pretty cool. All right, so there's the point. Now we want the slope, so we go f prime of x. F prime of x is equal to 2 derivative cosine, negative sine. Derivative 1 is 0. Plug in pi over 2. F prime of pi over 2 is equal to negative 2. You see that? So our equation is, our approximation f of x is approximately, okay, if we go y equals mx plus b, well, let's not use y equals mx plus b. F of x is approximately negative 2 x minus pi over 2. And now if f of x minus, we'll add the 1 over there. Everybody see what I did there? Okay, it should be like this. Y minus 1 is equal to negative 2 x minus pi over 2. But if I'm going to move that over that side just so I could get actual what f of x is right there. So we plug in. The question is, what's the approximation found at 1.5? So I plug in 1.5 right there. So I go over here. Let me go off to the side. Let me try to keep it on the same screen. F of, I'll squeeze it in here, 1.5 is plus 1. Let's distribute. So we got negative 3 plus 1 is negative 2, positive pi. Okay, so negative 2 and a positive pi. We got C. Who asked about this? Now, how's that? How's that look? Does that feel okay? And then we could, someone asked about number 26. So take a look at that. Don't let me move on. You know how the rules were in class. They're the same as the rules here. Don't let me move on if you're not sure what we're talking about. Number 26. Limit. 26, take a look. 26 was a limit. So what's the first thing we do in any limit? We plug it in. We're going to infinity. Oh, okay, if we're going to infinity, now we got to think top heavy, bottom heavy, even Steven. Okay, so I got infinity on the bottom. Okay, and what do I got on top? Let's see. We got the limit. This is number 26. We got the limit as x approaches infinity. As we said, we got infinity on the bottom. That's easy. And then we got e to the 3x plus x. So let's see what happens. As I go to infinity, e to the infinity is still infinity. Infinity plus infinity is still infinity. What's natural log? Can you picture the graph of natural log? Everybody get a little morning exercise here. Do the graph of natural log. Lift. As this goes to infinity, infinity. So I have infinity over infinity. Okay, what should infinity over infinity make you think of? Pause the video and discuss. What should it make you think of? It should make you think of L'Hopital's rule. Okay, what do we got to do for L'Hopital's rule? Remember, if it's free response, you got to say, since the limit as x approaches infinity of natural log, because you thought of this already, equals infinity, and the limit as x approaches infinity of x equals infinity by L'Hopital's rule. You see, you got to say that if it's free response. Multiple choice, we're just going to take the derivative of the top as x approaches infinity. I'll take the derivative of the bottom. Okay, now I got to take the derivative of the top. So 1 over keep times e to the keep times 3 plus 1. Check. Take a look at your derivative right there. Make sure your derivative is okay. Everybody see that? 1 over keep. I kept whatever is inside the parentheses. Here's still another chain rule. So e to the keep times the chain rule. Derivative of x is 1. So that cleans up to be limit as x approaches infinity of e to the 3x times 3 plus 1 over e to the 3x plus x. And we do it again. Oh, look, if we do it again, we have infinity over infinity again. Okay, now we'll get back to this, but notice, watch what can happen right here. So infinity over infinity again, we take the derivative again. Okay, so I have the limit as x approaches infinity. We take the derivative again. I have over here, I have 9e to the 3x on top, and I have 3e to the 3x plus 1 on the bottom. Look, I got infinity over infinity again. So I take the derivative again, and I have 27e to the 3x over 9e to the 3x. These cancel, and I have 3. And there's your answer. Now, as I said, we're going to revisit this, because notice, if you're thinking of your top heavy, bottom heavy, even Steven, you could still do that right now. after one L'Hopital's rule, because this is even Steven. And the coefficients are 3 over 1. They're the same e to the 3x. Okay, we know as we keep taking the derivative, this is going to stay and this is eventually going to go away. So it's even Steven. So at that point, you could have stopped and said 3. Number 26. Who asked for about 26? Rhea, how's that? Is that okay? And then we're going to go to 27 here. Take a look at that. Don't let me move on if you're still confused by something. All right, 27. Who asked? Dana, 27. Okay, here's 27. We got the graph. We got a graph of the derivative. Remember, this is the graph of the derivative. Okay? Which of the following statement is true? The function is continuous. All right, if derivative, is the derivative continuous? Since the derivative is continuous, the function is continuous. Okay, so 1 is definitely true. So right away I can eliminate D. Remember we had our nice little alphabet CD. If it made it to D, it had to be C. Okay, so now F is decreasing. Okay, again, translation. These are synonyms. Remember our synonyms. F is decreasing, but I don't have F. I have the derivative. Okay, so F is decreasing is a synonym for the derivative is negative. Is this derivative negative? Well, not always. From A to B, the derivative is positive right here. Okay, so what you want to do is, as you're going through this, when you want to say F is decreasing, you want to scratch that out and change it to F prime. Use the synonyms. F prime is negative. Okay, and then here's another one. F is concave down. We're going to translate to that. F is concave down is saying F prime is decreasing. And just for completeness, F double prime is negative. You see, we want to translate on number 27. We want to translate all this in terms of the content of the problem. The problem is F prime, so I want to translate these to F prime. So instead of reading F is decreasing, I'm reading F prime is negative. No, F prime is not negative. F is concave down, I translate F prime is decreasing. All right, let's look. Is F prime decreasing? Yeah, F prime is always going down. Okay, so the answer must be C. That was number 27. Dana, yes, what do you think about that? Did that make sense? Translating into the synonyms because we were given F prime. Okay, let me know if you were good with that. Well, I move to 23. Okay, let's look at 23. Okay, 23, we got a little region enclosed by, a little area one. Okay, we draw no calculator on this one, so we got a parabola. You should be able to do a parabola. And then we got the line. We find the intersection points. Here is 0, 0. Here's 2, 4. Right? The cross section's perpendicular to the y-axis. Let me get my pen. Let me draw it perpendicular to the y-axis. Okay, so perpendicular to the y-axis, and the cross sections are rectangles. So we'll draw let's do a different color here. We'll draw the rectangles. There's the rectangle. Okay, where's that rectangle sitting? That rectangle is sitting right there. You see, the base is that line right there. Okay, remember, for these, we always draw our practice rectangles. Make sure it makes it a lot easier. This is the easiest way to do it. Okay? And this is base times height. So, the integral right away, I know it's dy. That's the first thing you do. It has to be dy. The practice rectangle is perpendicular to the y-axis or horizontal, if you want to think of it like that. And the area is base times height. We know the area of a rectangle. Smallest y value, 0. Biggest y value is 4. So right away, I'm eliminating C and D. Take a look. Use the problems you're sent. I know it's y, since it said perpendicular to the y-axis. I know it's y, so it has to be A or B. Let's see where we go from there. So now notice we got to get B in terms of y and H in terms of y. Well, it says the height is 3 times the base. So height is 3 times the base. So now I could do it again and get the height 3 times the base is 3b squared dy. Well, there's that 3, but that didn't help me. It's still a or b. Okay, so now I got to say, all right, y. Let's see what y is. If this is y equals x squared, this is x equals square root of y. If this is equal to y equals 2x, then this is x equals y over 2. You see, you got to solve for y now. And then we say right minus left, as we always said. Bigger minus smaller. Okay, so this is going to be the integral from 0 to 4 of 3. Remember, that's how we prepped it. And we're going to put in bigger minus smaller. Always bigger minus smaller. So square root of y is the one to the right. Square root y over 2 is the one to the left. Minus, must be a then. Bigger minus smaller right there. How's that looking for you? And then Zoe says, let's do 15. Vishal, let me know what you think about that. And let's go to 15. All right, here's 15. Can you see that? Okay, we got graphs of f and graphs of g, which the following is false. Okay, now remember, okay, when we're combining things with multiplication, okay, here's the thing to pay attention to about something like that. When we're combining things with multiplication, we don't have the graph. Okay, so we got to go from the left and from the right. We'll get to that in a second. But A hopefully is pretty good. The limit is 0. Take my fingers. Is the limit 0? That's true. Okay, B, as approach 2, the limit does not exist. Hopefully that's pretty straightforward. Okay, but now when you want to find C, C is asking for the limit. This is number 15. C is asking for the limit as x approaches 1 of f of x times g of x plus 1. Okay, that's what they're talking about here. Now, in order to find that limit, since we don't have the graph of it, in order to find that limit, I got to split it up. I got to see what the limit as x approaches 1 from the left side of f of x times g of x plus 1. And then I got to see what the limit as x approaches 1 from the right side of that is. You see what I mean? Okay, so from the left side, okay, I'm approaching 1. So as I approach 1, for example, I'm approaching from the left side, so 0, 0.5, as I'm approaching 1 from the left side, this looks like, as it's approaching 1, this looks like it's going to 0. As I approach 1 from the left side here, notice I'm plugging in, 0.5, 0.9, 0.99. It looks like I'm approaching g of 2 from the left side. G of 2 from the left side is, you don't see the graph, I'm sorry. Let me say that again. Okay, I'm approaching this from the left side. Okay, so I'm plugging in. Remember, let's make a table if you're ever unsure. I'm plugging in 0.5, 0.9, 0.99, 0.999. Well, this is getting close to f of 1, which is 0. From the left side here, this is getting close to 0.5, 1.5, 1.9. This is getting close to g of 2, which is 1. So this is 0 times 1. This is 0. Now I'm approaching from the right side. Okay, if I approach from the right side, 1.5, 1.1, 1.01. As I approach from the right side, this is getting closer to 0. This is getting closer to negative 1. So this is 0 times negative 1, which is 0. So this limit is 0. The left side and the right side are the same value. You see what I'm talking about there? Okay, whereas let's do the same thing on this one. Okay. Limit as x approaches 1 from the left side of f of x plus 1 times g of x, and versus the limit as x approaches 1 from the right side of f of x plus 1 times g of x. Let's take a look at what that looks like. From the right side, so as I approach the left side, this is going to f of 2. F of 2 looks like to be about negative 1. F from 1 from the right side, of g of 1, G of 1 is 1, so this looks like negative 1 times 1. Everybody see that? And then I say, from the right side, f of 2, I'm getting closer and closer and closer to 2. Okay, f of 2 looks like to be about negative 1. G of 1 is 1, so it's negative 1 times 1. So this limit is negative 1. Everybody see what I did? In order to talk about a limit, since you don't have the graph of f of x times g of x, you got to look from the left side and you got to look from the right side. Okay, so now let's see which is true. This one, C, does not exist. False. It does exist. We said it was 0. This exists. True. It does exist. It's negative 1. Okay, so the correct answer is C. That's the one that's false. Okay, so don't get confused by that. But the point to make is if you want to find the limits, you got to do it like this, especially if you don't have the graph. Who has Zoe? What do you think about that? Number 15. All right, so here's the plan. Okay, the plan is, let's get in the camera. The plan is this. I could talk to you, hold on, face to face. Aha, here I am. Okay, here's the plan. Okay, uh-oh. Is it? Well, wait till when I stop the stream. When I stop the stream, you'll be able to pick and choose any part of the stream. But now you can't. You can't back up through it since it's a live stream. All right. So finish going through the test. We did a lot of the no calculator, but the with calculator ones. Make sure if you have any questions on the with calculator ones. Let's make sure the answers are on the PDF also. And then I want you to go through the objective sheet. Okay, and go through that objective sheet right here. And make sure, with your binder open, make sure you all those are covered that are on the test. Because like I said, probably it's going to be open notes. It's going to be with calculator. But you're not going to have time to fumble around looking for stuff in your notes. And so if you've been coming up with the binder all along, this should be no problem whatsoever. Okay? All right. Hopefully we got a lot done today. That was good. And I will see you tomorrow, 7:30. And when Schoology goes down, make sure you get that off of Schoology before everybody else gets on at 9:30, 10 o'clock after everybody sleeps late. I like you guys are getting here up in the morning. That's the way to go. Okay. So I will say the same thing the ocean says to the shore. See, it doesn't say anything. It just waves. Bye-bye.